Hi, today we're going to be on our new unit. We're starting our new unit. So we're going to start with patterns and sequences. You're going to turn to page 85. So if you like puzzles or patterns, this might be a unit that you love. Up here, a sequence is a pattern involving an ordered arrangement of numbers, geometric figures, letters, or other objects. So a sequence is just a pattern. Sometimes it's numbers, sometimes it's shapes, sometimes it's letters, sometimes it's other objects. And then a term of a sequence is the individual number, figure, or letter in the sequence. So a sequence is the whole thing, the whole pattern. And then a term would be like the third item in the pattern or the fourth item in the pattern. We're going to try to get through 10 examples between today and Monday of different sequences. For each sequence, we're going to describe the pattern, draw or describe the next terms, and then represent it numerically. So here, this one's called positive thinking. Take a minute and look at the pattern. What do you notice? So you might have noticed that there's a lot of dots here and they start to decrease. Let's look at how many dots they each have. So go ahead, pause the video, count how many dots are in each sequence. Excuse me. So I counted in the first one. So in the first term, there are 25 dots. Make sure you count that middle one. The next term, there are 21 dots. Then there are 17 dots. Then there are 13 dots. So how could you describe the pattern? It's definitely decreasing. How many are you decreasing by? So to go from 25 to 21, 17, and 13, you're losing 4 dots each term. You're losing 1 from each end. So we could write that you're decreasing by 4 dots, which means you're losing 1 from each end. You're going to draw the next 3 figures of the pattern. So I don't want you to get caught up in like drawing all the dots. You could instead write how many dots that there would be. So this is the first, second, third, fourth term. So in the fifth one, if you subtract 4 dots, there should be 9 dots. Then the sixth term, if you subtract 4 more dots, there's going to be 5 dots. And then in the 7th term, when you subtract 4 dots, there will be 1 dot left. We're going to represent it as a sequence. That means just write out the numbers. So you started at 25, 21, 17, 13, 1, 2, 3, 4, 9, 5, and then 1. Then we can fill out this table. So term number 1 was the one with the 25 dots. Term 2 had the 21 dots. You can fill out the remaining dots. Okay, over here, this part's important. All numeric sequences, so all these patterns will be functions. Remember, we just came off of the test that had functions or not of functions. And that is because the independent variable is the term number, that's your x, beginning with 1, and the dependent variable, that's your y, is the term of the sequence. And so looking here, term number 1, 2, 3, 4, 5, 6, 7, those are your x coordinates. Term values, your y coordinates. So these are, all our sequences are going to be functions. They would all pass the vertical line test because each input, the term number, goes to one output. Okay, we're going to flip the page to another pattern. This one's the family tree. So Jessica's investigating her family tree by researching each generation or set of parents. She learns all she can about the first 4 generations, which include her 2 parents, her grandparents, her great-grandparents, and her great-great-grandparents. So thinking about the number of parents, describe the pattern. So go ahead and pause the video. See if you can describe the pattern. So she is starting out with the parents, and then they all have parents, and then they all have parents. So you could see each generation has 2 times the number of parents as the generation after it. Okay, let's fill out the table, and then that might help with the explanation. So if there's term 1, 2, 3, 4, 5, 6. So you start off with 2 parents, and they both had parents, so now there's 4 people. Those 4 people each had parents, so now there's 8. Then those all had parents, there's 16. And then after that, there's 32, and then 64. So to determine the number of parents in the 5th and 6th generation, the 5th generation had 32, and the 6th had 64. To represent it as a numeric sequence, you're not writing the term number, you're going to write the term value. And we're going to write the first 6. So we're going to write 2, 4, 8, 16, 32, 64. Did anyone notice a pattern here? So it looks like you're multiplying by 2, and if you think back to our unit with exponents, this could actually be 2 to the 1st, right? And then 2 squared, 2 cubed, 2 4, 2 to the 5th, 2 to the 6th. So if you wanted to later, this is not part of the question, but later if you wanted to know the 10th generation, you could do 2 to the 10th. Okay, I'm going to go to, excuse me, collection of squares. And at any time, you're welcome to pause the video, try filling it out on your own, and then checking the video and see if we get the same thing. So for a collection of squares, look at the number of small squares in each figure. Describe the pattern. So if you count the squares, I believe this is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So a 7 by 7 would have 49. This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 by 6, 36. This one's a 5 by 5, so that's 25 squares. 4 by 4 is 16. So to describe what is happening, these are actually perfect squares, right? 7 times 7, or 6 squared, 5 squared, 4 squared. So you could say the number of small squares, that's the inside squares, are decreasing perfect squares. But you started or are beginning with 7, because you started at 7 squared and then 6 squared. You could also say you're losing a row and column. So to draw the next 3 figures of the pattern, I'm not going to do that because it's going to look like a mess. So after 16, which was 4 squared, the next one would make sense, would be 3 squared, right? So that's the 5th term. So 3 squared would have 9 squares. The 6th term would be a 2 by 2 square, so that would be 4 squares in there. The 7th term would be 1 by 1, which would only have 1 square. We're going to fill out the table, put in the number of squares, so 49, 36, 25, 16. Hi, Eddie. 9, 4, and 1. And then we're going to represent it in a numeric sequence. So starting at 49, because you start at the first term. 16, 9, 4, 1. Okay, let's flip to 87 for Al's omelets. So Al's House of Eggs makes omelets. Al begins each day with 150 eggs to make his famous Western omelets. After making one omelet, he has 144 eggs. After making two, he has 138. After making 3 omelets, he has 132. So think about the number of eggs Al has after making each omelet and describe the pattern. So this time, I'm going to try filling out the table first and fill out what we know. So he started with 150 eggs. After one omelet, he has 144 eggs. And then now he has 138 and then 132. So try writing down what's happening. So it's definitely decreasing, right? Because he's using the eggs. How many eggs is he using each time? 150 to 144, you lost 6 eggs. And then you lost 6 eggs again. And then you lost 6 eggs again. So it looks like Al has 6 fewer eggs after making each omelet. Let's figure out the number of eggs after he makes the next 2 omelets. So that would mean after, because we stopped at 3 omelets, so after 4 omelets, how many is he going to have? So if we take away 6 more eggs, he's going to have 126 eggs. And then after the 5th omelet, so if you go down to the next omelet, he's going to have 120 eggs. Oops. Okay, we can represent that as a sequence, so we would start at 150, 132, 126, and 120. Okay, let's look at Donna's daisies. Donna's decorating the top border of her bedroom walls with a daisy pattern. She is applying decals with each column having a specific number of daisies. So think about the number of daisies in each column and describe the pattern. So again, I think I'm going to do the table first. I think that helps me see the pattern. I'm going to fill out all the term numbers. And then I'm going to look at how many daisies there are. So there's 3, 4, 2. 3 daisies, 4, 2. So what's happening here? It looks like it repeats, right? 3, 4, 2, 3, 4, 2. So we could say the number of daisies repeats in a pattern of 3, 4, 2. I'm going to put dot, dot, dot. So in the next 2 columns, that would be the 7th and 8th term. So 7th column, if we look at our table, after 2, there should be a 3. Would have 3 daisies. And then the 8th column, after 3 should be 4 daisies. So fill out the table, write it as a sequence. So 3, 4, 2, 3, 4, 2, 3, 4. Let's do number 6, troop of triangles. I'm going to flip over. So look at this one, nothing to read, just picture to look at. You're analyzing the number of dark triangles, dark being the key word, so you're not looking at the white ones, you're looking at the dark triangles. I notice they're increasing, right? Maybe we should count by how many they're increasing, so go ahead and write down how many dark triangles you see. So I see 1, 3 dark triangles, 6 dark triangles, and then 9 dark triangles. So if you look at 1, 3, 6, 9, they're not increasing by the same amount, right? So this one, I'm going to change to a different color. You did +2, then you did +3, then you did +3, and then here you did, oops, I wrote down 9. Why did I write down 9? It should be 10. +4. So we could explain this. This one's kind of tricky to explain. We could say you start with 1 dark triangle and then add, so 2, 3, 4, those are called consecutive numbers. Consecutive means in a row. So you could say start with 1 dark triangle and add consecutive, meaning in a row, consecutive dark triangles starting with 2, right? Because you added 2 triangles and 3, 4, 5, 6, 7, 8. So to draw the next 2 figures of the pattern, I'm going to say the 5th and 6th figure because I don't want to draw them. So the 4th one had 10 dark triangles, and so we would have to add 5 dark triangles. So how many would that be? 15. Okay, now you have 15 dark triangles. You need to add 6 dark triangles. So how many would that be? 21. So let's fill it out in the table. And in the first one you had 1 dark triangle, then 3, 6, 10, 15, and 21. And then you can write it as a sequence also. 1, 3, 6, 10, 15, 21. I think we're going to do one more Gamer Guru and then we'll leave the rest for Monday. Actually, I wonder if we could get through all of them. Okay, Mika is trying to beat his highest score. On his video game, he unlocks some special mini games where he earns points for each one he completes. Before he begins playing the mini games, Mika has 500 points. After completing 1 mini game, he has a total of 550 points. 2 games, he has 600. 3 games, he has 650. So he's obviously gaining points, right? And how many is he gaining by? Looks like every time he gains 50 points. So Mika gains 50 points for each mini game he plays. Determine the total points after he plays the next 2. So let's fill out the table because I think that helps us see the pattern. So he started with 500, then he has 550, then he has 600, then he has 650. So the next one would be after 4 games, he's going to have 50 more, so that would be 700. And then after 5 games, which would be the 6th term, he should have 50 more, so that would be 750. So we filled out the table. You can write it as a numeric sequence. Okay, we have 1, 2, I think we only have 3 left. So I'm going to flip to the next page, Polygon Party, just shapes. Analyze the number of sides in each polygon. So I notice this one has 3, 4, this is a pentagon, it has 5, this is a hexagon, it has 6. So it looks like you're adding or increasing 1 more side, right? Each time you get 1 more. So the next 2 figures of the pattern, so the 5th figure would have 1 more side, so 7 sides. And the 6th figure would have 1 more side, so that'd be 8 sides. This one was a fast one to fill out. We can write the sequence. Okay, here's the pizza one. Jacob is participating in a pizza making contest. Each contestant has to bake the largest and most delicious pizza they can. Jacob's pizza has a 6-foot diameter. After the contest, he plans to cut the pizza so that he can pass the slices out to share. So he has one whole slice. I'm gonna just draw a picture. Or one whole pizza. Then he cuts it in half. And then after that, he cuts in half and half and half. So think about the size of each pizza slice in relation to the whole pizza. So you're not thinking of how many slices he has, you're thinking about the ratio of slice to the whole pizza. So I'm gonna fill out the table first. In the beginning, he has one whole pizza. Then he cuts it one time in halves, right? So he has halves. And he cuts it another time. Those halves are cut in half. So what is that? If you cut it half in half, that's a 1/4. Cut it again, it would be an 1/8. Cut it again, it's a 16th. Cut it again, it's 1/32. So to describe what's happening, you could say after after every cut, each slice is half of the previous slice. So the size next to the whole pizza after the next 2 cuts. So after 4 cuts, right? Because here we stopped in the story at after 3 cuts. So after 4 cuts, it's going to be term number 5. So that slice will be 1/16 of the whole. And after 5 cuts, that's the 6th term. That's 1/32. We filled out the table. Write the sequence. Okay, I'm going to flip the page to the last one. Coin collecting. Page 92. Miranda's uncle collects rare coins. He recently purchased a rare coin for $5. He claims the value will triple each year. So even though it's worth $5, it'll be worth 15, 2 years, 45, 3 years, 135. So it's obviously increasing. How is it increasing? It says it tripled each year. So each year, the coin value is 3 times greater than the previous year. So after 4 years, how much will it be? At 3 years, it was 135. So 135 times 3 should be 405. And then after 5 years, you're going to multiply the 405 by 3. What a nice coin. It'd be worth $1,215. We're going to fill out the table. 5, 15, 45, 135, 405, and 1215. And then write it as a sequence. Okay, great job getting through all of those sequences. That was a lot. So if you have extra time in class, you are going to update your IXL diagnostic. And then after that, I think it's only 6th period. We haven't filled this out yet. So you want to fill out from your diagnostic score here. That's from the rainbow wall. When after you finish the initial diagnostic test, it tells you your scores. And then down here, you can work on any of the recommended skills from the rainbow wall. You want to get a score between 80 and 100. And then you're recording them. So you record the date, what category it was, the code, the skill name, and then your score. For every 10 that you get, I will stamp it off, and then you also get to spin the wheel of prizes, or also known as the wheel of death. But I only check it for every 10, okay? So don't show it to me when you only have 4 done. All right, have a great weekend.